Hey everyone, my name is Dimitri. I'm the owner of Iris Paramotor LLC. We're located here in Washington State, and I basically build paramotors for a living, which is pretty exciting. So I'm guessing you found this video from a link from some sort of a group or other place that has to do with two-strokes, which is not my usual community. So I wanted to introduce myself so you know who I am. Um, so in this video, I want to introduce you to a pretty useful technique. And the technique is designing, first of all, designing in CAD, in Fusion 360 specifically, designing a two-stroke resonator, but designing it in a way where it's parametric, where you can always go back and edit any part of it and it updates. But more importantly, to be able to produce the flat patterns for cones that can later then be rolled, cut and rolled, and then welded into uh, any pipe that you want. Um, Now, we're developing an engine right now, so I'm doing this pretty frequently, and I feel like I found a really good way to do this in Fusion. Now, you may have whatever thoughts you have about Fusion. There are probably better tools to do this other than Fusion. Um, I've certainly spent a lot of years working in SolidWorks and even crappy old, Bobcat programs like that. Um, so Uh, I really like Fusion because of how well it integrates with my mill, so I use it every day to develop all of our products. And it's a little bit finicky to do it in Fusion, to be fair, but it does work, and I think this method is pretty good. So the goal for this video is to show you how to draw a sketch of the pipe, and then produce it into a three-dimensional part that works. Um, but then the trick here is this is sheet metal. So in Fusion, you can't just go from a solid part to a sheet metal part from cones easily. So you have to do some tricks to make it so that the cones become a valid sheet metal part that can then be unrolled to create these flat patterns that can then you can do whatever you want with. So you can get it laser cut, you can cut it yourself, whatever you need to do. So that's the goal of this video. So let's jump into it. It's kind of a long one, but I think this process makes it a lot easier than doing it most other ways that I'm aware of. So hopefully this gives you something. If you like it, please like, subscribe to our channel, and then we'll go from here. So let's get started. All right, let's jump right into this. We're in Fusion, new. Keep in mind this is new. Hybrid design is kind of like what it used to be, like where each part is also an assembly. So let's do that. Hybrid design. You might have to do just new part or whatever from a previous version if you're still using one. Let's start. We're going to start by making a sketch of the pipe. So let's do that. I'm going to pick a plane. It doesn't really matter how you start. And I'm going to draw the side representation of the cones. So let's say, I don't know, 30 millimeters we'll start with. Let's do 40 millimeters, okay? So I'm drawing the first cone. What I can do now is if I know the dimensions that I need to be using, I can hit D, and then I can set my dimensions here. 70, 80, because I want it to curve, and this is how much I want it to increase by. Sure, 65. Sure, why not? Okay, I'm going to draw the next cone. I'm only going to do a few cones because this is just an example. Again, I can go dimension, D, sure, 140, sure, 125. Obviously, I'm just plugging in random numbers, plugging in. Next cone, I'll just do 3 cones just to show you this. D for dimension, 189, why not? 160, okay, 160. This is not fully defined. What I can do is I can define the angles, but I don't think that's necessary right now. Let's actually do that just to lock things down a little bit. 98, sure. Sure. So this will, or oops, this will kind of constrain this in how it moves. So I can move the whole thing. If I remove this angle, I can still move. Oh, I have to lock it down. So let's constrain, fix, sure, I'll fix 1 point. See, now I can, whoa, I can move this cone still carefully. But this part is locked now, so I can't, it stays, so I can move just the last cone that I added if I want to tweak it. Or you can remove those constraints and then just keep the front, and then, but see, if you don't constrain anything, it starts to move like this, which is a little bit unpredictable. Anyway, sure, I'll leave those angles in place. We're going to call that good. That's going to be our 3 cones. Obviously, we need more to do a full pipe, but this is a good place to start. We're going to finish sketch. Now, you can see this is the flat representation of our pipe. Now what I'm going to do is I'm going to add a component, new component. We're going to add a component for every cone. So I'm going to do just one. I'll call it that, okay? Now what I need to do is I need to create the round, here I'll just show you, the round, the circles that represent the 2 cone ends. I'll put it that way. So we're going to do a plane at angle, and we're going to take these vertical lines that separate the cone sections. So I'm going to take this one here, and this drew a plane that is in line with the sketch, but I'm going to turn it 90 degrees. So as you can see, what I just did is I put a plane on the end of that line, on the end of the cone, basically. I'm going to do another one here, plane at angle, 90 degrees. So see, now I have 2 planes between the cones. Now, here I'm going to pretend I'm modeling the inside of the pipe. This is important. I could also just say I'm modeling the outside of the pipe, but I've decided here that I'm going to be doing the inside of the pipe. You'll see why in a second. So I'm going to create a sketch now on one of these planes. I'm going to rotate so I can see that line again. And what I'm going to do is I'm going to say create, project include, project. I'm going to grab that line, but I'm going to do line type as construction so it doesn't interfere with my circle or with creating a loft later. Just, you'll see. Finish sketch. Okay, so sorry, not finish sketch. So I've drawn that line. Let me go back into the sketch. And now I'm going to draw a circle, but the circle I'm going to draw from the center of that line that I've got to one of the points. So now there's a two-dimensional circle representation of that flat line. And now I'm going to offset it by the thickness of my metal. So let's say 1 millimeter. Sure, why not? We're going to finish the sketch. We're going to create a new sketch. We're going to go to this plane, and I'm going to rotate it again where I can see it. Create, project and include. You can just press P on your keyboard, by the way. I'm going to do line type as construction again. I'm going to pick that line. Okay. I'm going to turn off construction mode now. I'm going to draw a circle. Oops, I missed. Also, I'm not on the center of the line. You want to see that triangle snap. Oh, Jesus. I could drag that, but I'm going to just draw it again. Okay. Offset 1 millimeter. Sure, why not? All right, so I have everything now I need to model my first cone. So what we're going to do is make a loft. Loft from this to this. Now what's kind of annoying is this makes a solid loft. I wish there was a way to do just the section that I collect the blue, where it would have a hollow loft. I haven't figured out how to do that yet. So I'm going to have to do this in 2 lofts. So I'll do this loft, which makes the body of the cone. I'm going to hide it, show my 2 sketches again. I'm going to do another loft with only the center, the inner circle. You see what I mean? I highlighted just the inner circle. I'm going to bring my body up, and this automatically recognizes that I'm trying to do a cut, and then I'll do a cut. I can hide the sketches now for now. And now you can see I've made 1 cone. I'm going to do this very quickly for the other cones. So I have 1 part. I'm going to leave the second sketch up. Now I'm going to go back to my original document. I'm going to make new component. Oh, I'm going to name it 2. Oh, not 3, 2. Okay. Construct plane at angle 90 degrees from that line. On that line, create sketch. Whoa! Nope, that's not what I meant to do. Create sketch. Click that plane. Rotate where I can see it. Create project. Construction. Make sure to have the construction. There's my line. I'm going to draw a circle. Not construction. Circle. Then offset that circle by 1 millimeter. Finish. I have my second. We're going to create a loft. I'm going to hide this first body so it's out of the way. From here, from the previous sketch to the new sketch. Sure. Okay. I'm going to hide it so it's out of the way. Toggle my sketch back on. Loft. Circle, inner circle to inner circle now to make the cut through the center. Okay. Now we have 2 cones. Back to the main document. New component. Okay. Construct plane at angle. That line 90 degrees. Create sketch. Rotate where I can see. Create. Project include. Project. Or just hit P on your keyboard. Construction. Okay. Circle. Not construction. Grab that center. Grab that point. Offset by 1 millimeter. Okay. Solid loft. Oh, I don't have my sketch visible because, oh, I do have my sketch visible. Yeah, okay. Let's hide that body so it's out of the way. From here to here. Okay. Okay. And then bring my sketch back up so I can use it again and hide the body. Loft. Now just again, the inner circle to the inner circle. Show the body. Automatically recognizes a cut. Okay. Boom. I'm going to go back to the document. And now I'm going to hide some of these sketches because now they're just in the way. You can see our base sketch. Might as well leave that up. Going through the center of the pipe. And now we have our pipe with 3 cones. So now this is a valid model, valid solid model. And what you can do is you can go back to the original sketch. And you can edit any of these dimensions. Say 190, 210. Sure. And it updated right away, so you have a valid 3-dimensional geometry. Now, here's the catch. This needs to be sheet metal, and there's sheet metal is like, if you think about it, I lost my parts. Sheet metal is a flat part that gets rolled up, but to do the opposite, you have to unroll this. But there's no way to unroll a continuous like cone that's modeled in CAD. So now what we need to do is we need to effectively turn this into a valid sheet metal part. To do this, we're going to cut a hole in it effectively all the way down. And then we're going to add an extrusion that's flat, that will make a flat spot on the cone, which will be the starting point for the sheet metal part to work. Okay, so I'm going to make a new sketch. I'm going to click the same plane that I used before. Whoa, actually, I'll just click the sketch, the original sketch, which will give me that plane. And I'm going to hide the original sketch now because we don't need it. Okay, and I'm going to roughly draw a sketch kind of through the center of the pipe. And then I'm going to continue it. Where is it? Oh, what? Hold on. Oh, my sketches aren't visible. Where am I making a sketch? Oh, okay. Well, okay, I hid the sketch that I was editing. I'm going to finish this. Right, so I drew like a line through the center, and then I finished it off to make a complete shape. Now, what I'm going to do is I'm going to make an extrude. let's say by 3 millimeters. Sure, why not? 3 millimeters. And it's automatically recognizing it as a cut and wanting to cut all three of our parts. Okay, so now we have our pipe with a little piece missing. And now what I need to do is to make a little flat section that's just a simple extrusion, which will allow Fusion to recognize this as a valid sheet metal part. So I'm going to do an extrusion on each part. I'm going to go boop. I'm not going to go to 3 millimeters. I'm going to go slightly under. I'm going to go 2.8 millimeters. Sure, why not? Did I do it on the right side? Sure, why not? Okay, extrude. I'm going to rotate where I can see this. 2.8. Extrude. 2.8. Now, this is close to a valid sheet metal part, but it is not. You cannot convert this into a sheet metal part. The reason is this is not, when rolled, how sheet metal works. It's not a perfectly symmetrical cylinder. So here's what you got to do. We're going to first convert this to a surface. I know there's a lot of steps. Okay, we're going to go to the Surface tab. We're going to create offset. We're going to grab the interface. And offset is 0 because we're just basically grabbing the interface and then in a quick way turning it into a new surface. I'm gonna, oh, shoot, I'm gonna undo that. You gotta select each cone. I'm working backwards here from the big one, I guess. So I selected the cone so it creates the surface inside of this part. Create, offset, grab the inner, 0 offset, new body, cool. I'm gonna hide the original body. See, now I have just the surface. Oh, it didn't grab the... Okay. Wait, did I screw this up? No, okay. I didn't grab the small face here. I'm going to grab that too. Okay. Now, to make this valid, so you can turn it into a valid sheet metal part, I'm going to go create, still in the Surface tab, thicken. I'm going to... I don't think I did this right, by the way. Okay. Yeah, I didn't do this right because I didn't do the extrusion on the right side. I'm going to back this up. Okay. Okay. So I screwed up. I screwed up these 3 extrusions because I did them on the wrong side. Let's see which side I did them on. Yeah, you see what's going on? See here, if you look at it from this angle, the sheet metal is pointing down. So that little piece I extruded is on the wrong side. Okay, I'm going to back this up to here, to where it was just cut. Do that again. Solid, extrude. I'm going to do it from this side now. 2.8. Let's see how that looks. Yeah, that's better. Okay. Yeah, you see this is higher than this. That's what you want. Extrude. 2.8. Extrude. 2.8. Okay. So back to my last cone. We're going to go back to surface, create, offset, grab that. Yes, it's grabbing the whole thing now. Now it's valid. Okay. 0 offset, hide the body. Yeah, perfect. Okay, this is what I want. Now, create thicken, 1 millimeter. Sorry. So he's trying to, right now, thicken it into the inside, but we want to thicken it in the direction we started from because we're on the inside face right now of the pipe. We're going to go -1. Okay, -1. Okay, boom. So now we have a body that is a solid, but rather than being a perfectly symmetrical part, it is thickened from that face, which is a valid geometry that can be converted to sheet metal. See, now what I can do... Oh, and here's where that flat little part comes in, and there's a reason for it. So now you can go sheet metal, create, convert to sheet metal. Sheet metal needs a starting point. It needs a flat part. So when a part is rolled, it's the same way if you feed the flat cone into the slip roller, um, you're going to get a flat spot from where you started. So it's the same idea here. So I'm going to select this cone, but I'm going to select the flat part. Boom, boom. Steel, millimeters. Okay, cool. Now, this is what you want. You have now a valid sheet metal body that's has a flat spot where it starts. So now you can create a pattern of this part. So this is just one of the cones. I'm going to do that right now so you can see how this works. We're going to go create, create flat pattern. And by the way, this is why you want each cone in its own part, in its own component, because a flat pattern is created for the part. So if your whole pipe is in one part and you have multiple bodies as cones, then you can only have one flat pattern. So this is why I broke it up into individual ones. So now I'm going to click here on the flat spot. That's your starting point for the flat part, pattern 2. Okay, and it unrolled like magic, that cone. Now this is confusing because it's kind of odd. Like, where do you start? Where's this? Where's, what's right side up? What's upside down? Where's left? Where's right? So if you look here, there's an extra line. There it is, right there. So that was our starting point. That's on the inside of the pipe. So you're looking at the inside of the pipe, and this is the flat spot. So that's that edge. So what I do usually here is I'll go create a sketch on that face. That just copied that face into the sketch by default. And I'll create text here. And I'll go 1, but sure, okay. Where's my, what? Oh, it's really big. Okay, sure. 30. Okay. Okay, see now I have a sketch that has a 1 there, so I know that's the edge I would start rolling from because that's where the flat spot is. And I know this is the bottom of my part. And now what I can do is finish the sketch. And you can see it has all the elements I need. And I can right click on the sketch if I need to export this and export to DXF. And that would send it over to whatever you need to do with it. In my case, what I do actually is different. I just select this, copy it, finish sketch, and I go into my machining and I paste several of them, and I'm going to cut out. Or I would send these individual parts to my laser cutter guys and they would cut them for me. Okay, so this is done for one cone. We can finish this pattern. I'm going to quickly go through do this for the rest of the cones. I'm going to hide this one so it's out of the way. I'm going to go to this one. All right. Again, pretty simple. Surface, create, offset, click the interface, 0, hide the first body, create, thicken, select the cone or select that part, -1. It's already remembering that I did this, so it already remembers my thickness that I need. -1. Okay. Now it's valid for creating, converting to sheet metal. Sheet metal, create, convert to sheet metal. Click the flat spot, steel. I don't actually know if you have to click the flat spot there. Create, flat pattern. Here you do have to hit the flat spot. Okay. Unrolled cone. My little line is here, so I know that's my starting point. Again, sketch, create text. Okay. 2. Finish sketch. Oh, I just realized I'm doing my numbers backwards because this is cone number 2, but the other one was actually cone number whatever. It doesn't matter. I'm just doing this as an example. Finish flat pattern. And then we'll do the last one. Last cone. Done. Surface. Create. Oh, gotta highlight the part first. Create. Offset. inner surface 0, hide body create, oops, create, thicken. What's going on? I don't know what just happened. I did something weird. Okay, create, offset, inner, 0, okay. Oh, I don't know what that is. I don't know why there's blue. I don't know why the faces are highlighted. Anyway, okay. Create, thicken, -1, okay. Sheet metal, create, convert to sheet metal. Again, I'm not sure if you have to press that flat spot, but I just got on the habit of doing that because in the next step you do create flat pattern, boom, boom, boom. And that is our last pattern. Where's our line? It's right there. Okay. Sketch, create text. And again, I'm going to put 3, but this is actually cone number 1. So I did the numbers here backwards. Done. All right, so that was probably quite the ride. I realize it's a lot of steps, but if you try to think about what's actually going on and why those steps are taken as you learn that technique, it will all make sense because there's a logical reason for doing every one of those things. And it's just in the nature of how sheet metal parts are in Fusion or in general in real life, and it's just a representation of that. You're just modeling it correctly. Um, and again, it's really awesome because you can go back to the original sketch now. You can tweak your lengths to what you want, uh, and all of those parts moving forward are automatically updated. You might have to open up each pattern, each flat pattern, and it will update when you do that. But in general, just keep in mind once you export to a DXF or copy the sketch to another to your machining part or whatever project, then that's no longer going to be updated. You have to actually re-export the DXF or copy and paste the new sketch into the final form. But other than that, up to that point, everything is updated. So even if you add different joints in your big assembly of your engine or whatever, then all of that stuff gets automatically updated. It's pretty cool. Thanks for watching. Hopefully this helps you. Again, if you like it, please subscribe and hit like. That will help this video get around so more people can see it that need to see it. Or leave any comments if you have better techniques. I would love to hear them because I do this all the time right now, and I could sure, if there's any shortcuts you see, I would love to hear about it. Thanks for watching.